Hi there. So today we're going to solve this problem called contains duplicate. It's an easy problem. In this problem we are given an array and we have to check if any element appears more than once in it. And if yes, then we have to return true. If not, we can return false. So the first approach I can think of is that I can sort the array and check if any two adjacent elements have the same value. Okay. For example, if we take this array, if we take this array and we sort it, it will be 1, 1, then 2, then 3. Then of course 1 and 1, which are adjacent elements, are duplicates. Then we can return true. If if it was only 1, 2 and 3, we would have returned false. Okay, but sorting will take time complexity O of n log n, and the space complexity will be constant because we are not using any extra space. Okay, let's code this approach. We will use the stl sort function, nums.begin and nums.end. Fine. And now we compare adjacent elements. Nums.size -1. We have to subtract 1 because we will be comparing ith element and I plus 1th element. So if nums at I is equals to nums at I plus 1, we can return true because then a duplicate exists, and otherwise we can return false. Let's try to run this. No syntax error, basic test case pass, and let's try to submit it now, and that works too. Okay, so can we use memory somehow to trade the can we trade memory in return for a better time complexity? Yes, we can. We can use an unordered set, or we can use an unordered map to and when we are using an unordered map, we can check the frequency of each element. However, that will take two iterations, because in the first iteration we will get all the frequencies of all the elements, and in the second iteration we will check which of the entries in the unordered map have a frequency greater than 1, and then return true if if there is any frequency greater than 1, else we can return false. In unordered set, what we can do is we can form a unordered set with all the elements of the array, and if the size of the unordered set is less than the size of the array, we can return true because then there is a duplicate element. Okay, let's code the unordered set approach. We create an unordered set of integers. Let's call it us, and in STL we can directly create an unordered set from an array by using the begin and the end iterators. All right, and here we can return if the us.size, if the unordered set has a size less than the array size, then we have a duplicate. Let's directly submit it. So yes, this approach works, and this will be of a time complexity O of n, because unordered set also for each insertion unordered set will take O of 1, and for each and when we are checking the size, it is just O of 1. So we are inserting elements and each insertion takes O of 1, so that means O of n, and at most we might be inserting n elements, so the space complexity is also O of n. The time complexity is O of n and the space complexity is O of n. Thank you.